Okay, now, it seems that at this tutorial right now, we have done effective, I should say, and enough, we have taken enough steps to prepare two other objects which we needed to eventually run our first fit for Pareto distribution, to fit our Pareto distribution to, I should say, to our importance weights distribution, that this is going to be the topic of this tutorial. And in order to do that, I assume that still you have the package Loo, which is installed in your system. Then as a result, if the package is running and ready to use, I'm just going to go ahead with this function, which stands for Pareto smoothing importance sampling. And that's the thing we have. Look at that. It's going to be the function. You can just read that like that. Pareto smoothed importance sampling. That's PSIS comes from. And now, in order to just go ahead to just do this fit, I'm just going to press F1 to see that what objects do we need. The first object that we need here, you can see the help option opens here, Pareto smoothed importance sampling, which it says that it's an implementation of the Pareto smoothed importance sampling, a method for stabilizing importance ratios and importance weights. Okay, now in order to just do that, the first object which I need is gonna be, it says that it's gonna be a log ratio. The log ratio, that it means that we have to use, essentially, if I just want to go ahead and say that, okay, if I just want to go and say, what is my log ratio? The log ratios that we are just going to put that inside our function with the PSIS function is essentially nothing, just the model that we created above. I just want to go back to see that the thing which we just created above. In the tutorials before, we created a model, we called that like woman A, which it was essentially a point-wise log likelihood of your model. Then what did we have to do? We assume that in the Bayesian context that we are working, you have, I should say, your we have your R package installed and ready to use. Then if that package is installed, you have to just go to search for, you're applying the functions, which is going to be the log likelihood, which essentially that's the point-wise log likelihood. Then we have two objects to just put that inside that function. One of them, the model that you just fitted based on the R arm, which it could have been, for example, by stan GLM, and also an address for the data that you used. This model, which is a kind of a Bayesian regression that we did, alongside with the data what we did the fitting, it comes with the functions log like in the R arm to create the object, which we're just going to do that as the log ratio when we just want to do the Pareto smoothed importance sampling. Okay, in order to do that, I'm just going to come here. But also I have to say there is a minor trick before we move on for this fitting analysis. The first thing is that then, as I said, for the log ratios, which is an object for my PSIS function, I'm just going to say like woman A. That's the model which we extracted as a point-wise log likelihood from the R arm. However, there is a minor trick here, that the log ratio that you are just going to have for the PSSI, which is going to be the Pareto smoothed importance sampling, it has to be, I should say, a kind of an inversion of that, which it means that we have to multiply this one by -1, and I'm going to execute the line, and simply you see that the log ratio, which is going to be an important object to just go ahead with the Pareto smoothed importance sampling, it's going to be just a inversion or inverted version of the point-wise log likelihood, which we did, I should say, on the previous tutorial. Now, as long as we have the log ratio, which you know how it's just going to be created, I'm just going to go ahead to the PSIS function and simply just put the log ratio which I created just a second ago. This is going to be the first thing which I need for, first argument which I need for this model. Okay. For the second model, as you can see, we have, I should say, another, object, which is going to be the R effective, which you see that if you just go to the description of the things which you have done, it's a relative effective sample size. For the R effective, which we have here, it reminds you of the thing that we created just on the previous tutorial. Effective sample sizes that we said that because some of the samples that we throw from the posterior density, they are correlated with each other, we just extract those ones which are correlated, and whatever is left is divided by the total sample sizes, the total sample sizes which we draw from the posterior density. Based on that definition, we created an object which it was called an effective. It's exactly the previous tutorial that we did, and now it seems that the model that we wanted is now ready. I can create a name for it. I can just say that PSIS for woman. You can come with any name you want in your research, but the name which I picked, it's gonna be something that on, let's say, in a couple of days from now, if I go back to my R studio and I see that object, it reminds me that it's gonna be a Pareto smoothed importance sampling method on the woman datasets, which I fitted that before. Now it seems that we needed everything for this method, and I have to just execute this line by pressing Control Enter, and I have the method run. Also, sometimes you get some kind of a warning message, which I'm going to explain that to you when we just go for the Pareto K diagnostics, how to interpret that warning message, but that's totally fine. You can ignore that warning at this stage. When we just talk about the Pareto K diagnostics, we can see why we just got that message there. Then now, as the model is going to be ready, the thing which we want to do is we want to take a quick look inside that function. The first thing which I'm going to do, I'm just going to go ahead and just see the class of this object, which is going to be the PSSI woman. You see that it's a kind of a important sampling list. Okay. As now as I have it, I know that by doing this one, I have the weighted of my objects, I should say, to be extracted, to be having smoothed. Then now, what were the weights? Essentially, the weights that we did, if you go back, I should say, to these tutorials, the weights that we are talking about essentially are the posterior, I should say, they are the distributions which they have been divided by a proposal distribution, evaluated at every rows that we take from, I should say, from the proposal distribution there. Now, if we just want to do, it seems that this method, the PSSI, the PSIS, essentially, which is a Pareto smoothed importance sampling, has tried to smooth it, those weights that in their distributions, at the tail, they have been abnormal. And now, in order to see that what we have done, the thing which we can do is that we can just extract those weights from these objects that we just created. You see that there is one function there which is called weights importance sampling. This function, I'm just going to go ahead. As usual, we just want to have some clarifications on that functions, and I just press F1 and I have the help menu which opens there. The description of this function is that it says that it extracts importance sampling weights that from this model now it has been smoothed because of the, I should say, because of the fitting with the Pareto distribution. The objects which I need is going to be the objects which I created as a PSIS woman, and I'm just going to go ahead, press Control Enter and execute the line, and I see a bunch of weights which it shows, and essentially you expect to see lots of weights, around 4,000 weights. Now I'm just going to go ahead and I create an object. I take the weight, smooth it, and store that into that object. Weight smooth. Let me go ahead with the small s. It makes it much easier next time. I just want to type it. And now, look at that. You see that the class of the weights that we have created, weight smooth, is going to be a matrix. It should be a matrix because for every thousand, every samples, for each observation of those women, they had a weight inferred. And now that weight has been just, I should say, smoothed. And now, if you want to see the dimensions, you should not be surprised to see that if that's going to be the same weight, which is going to be 4,000 by 15, which we talked about that before. And you see that if you just want to see, for example, the head of, let's say, for example, the weight of the smooth, let's go ahead with the first three ones. You see that, for example, or just go with the first one. With the first one, you see that for each woman, we had an observation as the weights of our density distribution, I should say, to the proposal distributions. And now this one has been, I should say, it has been smoothed, and you see that these are the weights which is created right now. However, I have to just make a distinctions here. These ones which we have, essentially they are not the prediction of or the parameters that we were interested for. I mean that the slope or the coefficients, they are just the smoothed weights that we just wanted to just work with. Okay. Now, in order to just move on and continue with the other thing which I just wanted to see, it's always a good idea that you can also plot these weights that you have. I'm just going to go ahead and I say, okay, let's plot the weight smooth. Let's see what do we get. And you see that the plots which you get, it's going to be a kind of a clustered plots of the weights which they have been smoothed. You see that the weight smooth 1 and the weight smooth 2. And they have been all, I should say, plotted, and the plot should seem something like that, which is a kind of, I should say, a kind of a clustered into one point, I should say, in the plane that you have from between the part 1 and the part 2 of, I should say, of the weights that you have. Also, before we finish, it's also a good thing that if we can just at this stage do some kind of, I should say, diagnostics on the comparative smoothed important sampling which they have had, but also it's always before we finish, the thing which we can say that we can also, for example, look at this. We can go ahead with the objects which we created. Also, the objects which we created, it was called, let's see, the objects which we created, it was PSIS woman. That's the object which we created. And you see that if you just go ahead with the $, you can extract some of the things that is going to be relevant for our analysis. You have the log weights. These are essentially the weights that we had. And essentially when you plotted it, you plotted these log weights. And you see that the same plots is generated again. And that's essentially, that's what we did. When we plotted it, we were essentially plotting the log weights. And also, there is another thing that we just want to talk about, that is going to be about, let me just go to the PSIS objects which I created for the woman, and just go ahead with the $. There is also one case of the diagnostics. With diagnostics, which is going to be, I should say, the P, I should say, which is some kind of diagnostics, with a range of, I should say, the shape parameter of the Pareto distribution. Because if you remember from if I just go back to the whiteboard of the Pareto distributions that we talked, you see that for each shape parameter from 1, 2, 3 to infinity, you expect to have a different shape and configurations of your Pareto distribution when you plotted the density then I should say in that case, making it inference for the optimal, I should say, of the parameter space, the shape parameter is essential. Then that's the thing that we're going to talk about that when we come back on the next tutorial. We talk about, I should say, diagnostics of the shape parameter of the Pareto distribution, which is already fitted to our, I should say, our sampling importance weights then. I will see you then on the next tutorials with these diagnostics.